The question says we have this series n equals 1 to infinity of n to the 90 divided by n factorial. And the question is, does this thing converge? And we're supposed to use the, wait a minute, what are we supposed to use? Hold on, I have to look it up. I have to go here to remember what the question is. I cannot go back to the question there. I'm looking for the question here. Apply the ratio test. I don't know why I couldn't remember ratio test. All right, so the ratio test. The ratio test says that L, for some series AN, L equals the limit n to infinity of AN plus 1 divided by AN. AN plus 1 just means we replace n. Every n is replaced with n plus 1. And then there's three cases here. If this is less than 1, it's absolutely convergent. If it is greater than 1, it diverges. It's divergent. If it's equal 1, then it could be absolutely convergent, conditionally convergent, or divergent. In other words, find another test because this test didn't give us our answer. Absolute convergent means the absolute value of the series converges. It's a stronger form of convergence than conditionally convergent. But again, if this equals 1, if this L equals 1 when we take the limit, then we got nothing. Better go find something else. All right, what is AN plus 1? This is AN. This is AN. So what's AN plus 1? AN plus 1 is N plus 1 to the 90th power divided by N plus 1 factorial. And we're taking the limit of, what just happened? N to infinity. I don't know, a pen just appeared on my screen of that. Divided by n to the 90th divided by n factorial. Well, if you divide by a fraction, you multiply by the reciprocal. So this is the limit as n approaches infinity of n plus 1 to the 90th power. Oops. Oh, yeah, 90th power. I thought I made a mistake, but I didn't. Divided by n plus 1 factorial times the reciprocal of what was on the bottom. Having a hard time making dots here. N factorial divided by n to the 90th power. Well, n factorial is just n times n minus 1 times n minus 2. N plus 1 factorial is n plus 1 times n minus 1. In other words, n minus 1 can cancel with n plus 1 factorial and leave only n plus 1. And right now, there's nothing to be done with this n plus 1 to the 90th and n to the 90th. Now, on the numerator, n plus 1 to the 90th. In the denominator, n plus 1 to the first power. So, subtract those powers. 90 minus 1 is 89. So this is the limit as n approaches infinity of n plus 1 to the 89th divided by n to the 90th. This n plus 1 canceled out with one of the powers of that n plus 1. So it left n plus 1 to the 89th. Well, to take the limit, just look at the highest power of n. This 1 is negligible. It's so tiny compared to what n eventually becomes as n approaches infinity. So this is n to the 89 over n to the 90. And again, 90 minus 89 is 1. N to the 89 cancels over n. And the limit as n goes to infinity of 1 over n equals 0. And according to our test, if it equals 0, it's less than 1. It's absolutely convergent. So by the ratio test, I had to look it up again. I don't know why I can't remember it. By the ratio test, this n equals 1 to infinity, n to the 90 over n factorial is convergent, absolutely convergent. That's it.